Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So for today, we are still going to discuss additional application of derivative. This is the last part. We will going to other application of the derivative. Let's see. Okay, let's have a look at this fencing optimization. The highway department is planning to build a picnic park for motorists along the major highway. The park is to be rectangular, such as this one picnic park, with an area of 5,000 square yards and is to be fenced off on the three sides not adjacent on the highway. So this will not be included. So what is the least amount of fence? The least amount of fencing required for this job. So I want to minimize this. Okay, yeah? How long and wide should the park be for the fencing to be minimized? Okay, yeah? I want to preserve that the area should be 5,000. I want to minimize the fence, this fence, that is y plus x plus y. Don't forget, we have to define first specifically what is x and what is y. Okay, yeah? Let x be the length of the park parallel to the road in a yard, and y be the width of the park in yard unit. And then finding the relation, the area is 5,000 yards. What is a yard squared? So what is this? This is x times y equals 5,000. Okay, yeah? And I can simplify this into one variable because this I have y equals 5,000 equals x, and I want to uh, minimize the length of the fence. That is p equals x plus 2y. Don't forget y because the bottom is not included. Yeah, so I have x plus 2y instead of 2x plus 2y. X plus 2y, and y is this. I can substitute this. So I want to minimize this. Don't forget, x cannot be 0. Why? Because you will have a division by 0. Okay, so we have to find the minimum of this. Don't forget, this is just one variable problem because it has been simplified. Okay, first of all, I want to find the stationary point. So P prime should be given by this, and you can have this, and you can have this factorized, and the stationary point is given by 100 and minus 100. Don't forget, it can also change in x equals 100. So in this case, don't forget we have an interval that is not bounded. So no endpoints and singular point. So I have this one as the p prime diagram of sign. So okay, yeah. So we will just consider the positive x because x is the length. So I have to consider the positive. So it will be negative, it will positive, decrease, increase. So at 100, it should be a local minimum here. But from 0 to infinity, it will be a global minimum. Okay, yeah? So the length function p has local maximum at x, but here we conclude that x equal 100 is minimum value. This means y is this, and thus the minimum length of the fence is this, the 300 yards, while the minimum length and width are 150 yards respectively. Okay, yeah? And the last application is this. A manufacturer can produce souvenir t-shirts at a cost of $2 a piece. The shirts have been selling for $5 a piece, and at this price, tourists have been buying 4,000 shirts a month. The manufacturer is planning to raise the price of the shirt and estimate for each one increase dollar in the price, 400 fewer shirts will be sold each month. At what price should the manufacturer sell the shirts to maximize the profit? For this kind of problem, we have to define what is x and what is y and try to formulate the problem in one variable. The first of all, Formulation of the model, we define X to be the unit price of t-shirt in dollars, and PX be the profit from selling X unit t-shirt of t-shirt. Okay, defining the relation. Okay, so profit should be the number of t-shirts sold times the profit per unit t-shirt. Okay, yeah, it is easy. So the raise of unit price is X minus 5. Is now, if now the unit price is $6, it raised by 1. So the raise is given by 6 minus 5. If the unit price is increased to $7, so the raise is given by 7 minus $5. If I have X, so the raise should be X minus $5. Don't forget this, the increase from $5. Okay, yeah? And every one raise in price will decrease the demand by 400. So how many raise this is? X minus 5. 1, 400. $2 raise, you have 2 times 400. So if I have X minus 5 raise, you will have the demand is decreased by 400 times X minus 5. So the total number of t-shirts sold should be 4,000 minus the decrease, that is 400 times X minus 5. I can simplify this and I have this. Okay, yeah? Because X is just unit price, X should not be negative. Okay, X should not be negative. And the number of t-shirts should not be negative also. So 15 minus X should be positive. So X should be greater, so it should be positive. So you have X should be less than or equal to 15. Okay, yeah? And profit obtained from one t-shirt that is sold is given by X, the price, minus the cost, $2. Okay, yeah? So the profit is given by the number of t-shirts sold, that is this, times the profit, that is X minus 2. So I have this one. Okay, yeah? The profit is given by this. And we will maximize this just for X from 5 to 15. Why? Because don't forget, this is X minus 5 and it should be positive. So X should be greater than or equal to 5. But X should be greater than equal to 2 because the profit that is sold. Oh, no, yeah, the profit can be negative. Okay, yeah, the profit can be negative. So we will maximize px with x is also, this is a bounded and closed interval. So we don't have to find the monotonicity. Find the maximum of p. I have p prime is this, and the stationary is given by this. The endpoint is this, no singular point. And I can check that P5 is this, and this. So based on this check, I can conclude that X equals $8.5 is a maximum. Thus, the t-shirt must be sold in $8.5 with profit $16,900 to maximum the profit. Okay. And we have our alternative solution. We can define N as the raise of t-shirt in dollar. So the number of t-shirts sold should be 4,000 minus 400 times N. So N is the raise in price of a t-shirt in dollar. So for every 1 unit, it will decrease by 400, the demand. So if you have N raise, you should have minus 400 N demanded, that is decreased. Okay, yeah? So the number of t-shirts sold should be this. And the profit obtained from t-shirt is given by the raise plus the original price, that is 5. N plus 5 minus the cost, so I have N plus 3. So the total profit is given by the number of t-shirts sold times the profit, so I have this one, 4N from 0 to 10. Why? Obvious from this, because 10 minus 10 should be positive. The number of t-shirts should be positive. And what about 0 here? Yeah, N should be greater than minus 3. Oh, it is not. Okay, yeah, because N is the number of rays and the rays should be positive. should be greater than or equal to 0. And we will have the same answer in the end. Okay, yeah? There are another examples, a good one in the textbook. You could read it by yourself, especially on inventory control. Okay, yeah? This is the last part of the additional application of derivative. Okay, thank you very much.